Hi everyone, this is the second grade enhanced math week 15 solution video. Problem 1. To identify the value of the underlying digits which represent either thousands, hundreds, tens, or ones. Okay, so before we begin, let's define what these mean. So assuming that there's thousands, which means that 1,000 has 4 digits. So we draw 4 boxes for 4 digits. And we recall that the ones, which starts on the very right. So therefore, this would be ones, and it has 1 digit, whereas the tens is the second to right, which encompasses the 1. So from the tens, we have 2 digits. From the hundreds, we have 3 hundreds, which basically includes the hundreds digit, tens digit, and ones digit, which has 3 in total. And finally, the thousands, which is 4 digits, because 1,000 has 4 digits. Okay, now let's move on to this one. The first one is 678, and the 6 is underlined, which means that we have to identify the value of it. Well, we see that if we were to draw 678, the 8 would be in the ones because it's on the rightmost side. The 7 is the tens, and the 6 is the hundreds. So therefore, it's the hundreds. So I will just write hundreds. Next on moving on is 82. Well, rewrite 2 as the ones and 8 as the tens. And since there's no more, we can conclude that 2 is the ones because 2 is underlined, so therefore we write ones. Moving on is 108. This time the 0 is underlined, so we always repeat on the right side first. So 8 would be the ones, and then 0 would be the tens because we move from right to left, and then 1 is the hundreds. So therefore 0 is tens. Moving on is 325, 325, 5 being the ones, tens being the 2, and hundreds being 3. So 325, 5 would be ones. Next one is a 4-digit number, so we're going to use up the thousands place, and we always start from the right side, so 2, moving on to tens, 2, moving on 3, and 1. And this time it's the thousands because the underlined digit is in the thousands place. Next, moving on is 4,725. We can do 5, 2, 7, and 4. And because the 7th is in the hundreds place, then we just write hundreds. Moving on to 230. This time, 0 is the ones, tens is 3, and hundreds is 2. 0 would just be ones. Next one, 0, 9, 7, 4, 4,790. The underline is in the tens digit. And finally, 5,132, 2, 3, 1, 5. And the underline is in the hundreds. And that's problem 1. Moving on to problem 2. Write out the expanded forms of the following numbers. Well, we recall that ones is just 1 digit, so ones. Whereas tens, it has 2 digits, so I'm just going to write 1, 0. And then finally, hundreds, 100. And thousands, we'll just write 1,000. Okay. So write out the expanded forms of the following numbers. We start with 367, 7 being the ones, so it is 7. Plus 6, well, we remember that 6 in the tens digit just means 60, so therefore we write 60. And finally, we see 3 in the hundreds digit. Well, 3, that's basically just means 300. So 367, you could write it as 300 plus 60 plus 7. Moving on, again, following the same pattern, we basically do 6 because that's in the ones digit, followed by 90 because that's in the tens digit. So 90. And finally, 500, which is basically in the hundreds digit of 5. And there you go. Next one, 4,831. 1 is in the ones digit, so that's basically just a 1. 30, which 3 in the tens digit, that encompasses the tens and ones place, so that is 30. Plus the 8 in the hundreds place, that gives us 800. And 4 in the thousands place gives us 4,000. And then finally, in green, let's move over here. We see 5,112. Well, we see that 2 is in the ones place, so 2, and then plus 1 in the tens place, that gives us 10, and then 1 in the hundreds place, which gives us 100, and finally 5 in the thousands place gives us 5,000. Okay, and that is how you do problem 2. Problem 3, put less than or the greater sign in the blank. We start off with 320 to 290. Of course, we can look at the hundreds place first because we obviously see that 3 and 2 are not the same number and that 3 is greater than 2. And since that hundredth place is all that matters, so therefore we can just put a greater than sign here. 320 is greater than 290. Next one, we need to be a bit more careful because obviously the hundredth place is the same this time. So we need to move on to the tens place. The tens place, we see that there's a difference. The left one is 1, where the right one is 4. So 4 is greater than 1, so therefore we put a 415 is less than 444. Next one, 567 or 756, we see that 5 in the hundreds place is less than 7, so therefore we do a less than. Next one, 999 to 1000, this should be obvious. 1000 is a 4-digit number, whereas 999 is a 3-digit number, so 999 is less than 1000. Next one, we see that 608 or 806. Well, we can see that 6 is less than 8, and since that's in the hundreds place, we do 608 is less than 806. Next one, 7 or 5 in the hundreds place. We see that 7 is greater than 5 this time, so 715 is greater than 599. Same thing for the next one, 8 is greater than 7, so 827 is greater than 728. And this time, we see that it should be obvious that 200 is obviously greater than 129. We just look at the hundreds place first. So 200 is greater, 129 is less than 200. And the next one, we see that 2 is greater than 1 in the thousands place, so therefore 1,234 is less than 2,100. The next one, again, we look at a thousands place, 9 and 8. 9,310 is greater than 8,978. And moving on to the next one, 5 in the thousands place is greater than 2 in the thousands place. So this is greater. And the last one, 3 in the thousands place is larger than 2 in the thousands place. So we just do larger than. Problem 4. What is the difference between the largest 3-digit number and the smallest 4-digit number? So we do a 3-digit number in green and a 4-digit number in red. As we can see, in order to get the largest 3-digit number, we have to think of the largest digit that we can do, which is just 999. 999. And the smallest 4-digit number, well, we have to think of the smallest numbers that we can do. Well, first of all, we know that the first number can't be 0, so therefore we have to move on to 1. But that gives us 3 other choices to just make it 0. So therefore, 1,000 minus 999, that's basically just a 1 number difference. So the answer is 1. The difference is 1. Problem 5, put the largest number in the blank. 300 and something 4 is less than 370. And we have to put the largest number that still satisfies this. Well, obviously, we know that 7 can't work because otherwise that'd be greater than 370. So therefore, we just put 6. The next one, something 05 is less than 200. We know that we can't do 2 because 205 will be greater than 200. So therefore, our only choice left is 1. The next one, 765, is greater than 700 and something 8. We know that we can't put 6, right? Because otherwise that'd be greater. So therefore we put 5, which is the next largest number. And then 529 is greater than something 58. We can just do 4. 730 something is less than 738. We can just do 7. That would still satisfy. And then the last one, 1,402, is less than 1,000 something 99. For this question, the only possible solution would just be 3. Otherwise, 1,499 is so much greater than 1,402. And that's how you do problem 5. Problem 6, the digit sum of 998 is 9 plus 9 plus 8, which equates to 26. How many 3-digit whole numbers whose digit sum is 26 are even? Well, for this problem, we can see that obviously 9 plus 9 plus 9 is already 27, right? So in order to make this satisfy, we have to at least have two nines, right? Or else how is it going to reach 26? So therefore, 9 plus 9, that gives us 18, plus one other number, which is 8 equals to 26. And as you can see, this is obviously the only solution because you can't go larger. Like 9 is the largest digit, and 8 would be the biggest number that you can get to even get 26. So anything less than that will not get you 26. So therefore, there's only one three-digit whole number that gets you 26, and whose digit sum is 26. So that is even because 8 is even. So there's basically only one. Problem 7. Find all three-digit numbers that satisfy the hundreds digit is twice the tens digit and the tens digit is twice the unit digit. So let's write out the three-digit numbers. And then we see that the hundreds digit is, so let's write hundreds, H for hundreds, tens for the tens digit, and unit for the unit digit. And we see that the tens digit is twice the unit digit. So let's make the unit digit just, for example, let's make it into a star, okay? So this star represents the unit digit. And since the tens digit is twice the unit digit, we can put 2 stars. And then the hundreds digit is twice the tens digit, 2 times 2, that would just give us 4 stars. So now we just test out what the stars could be worth, right? So for example, if the star was worth 1, then, sorry, let's make this into green. If the star was 1, then that means the tens digit would be 2, and the hundreds digit would be 4. So that works, right? 421. And then let's see if there's any more. We can make the star into 2, which makes the tens digit 4, and then the hundreds digit, which makes it 8. And then as you can see, the next one obviously wouldn't work because, let's test it out just to make sure. If the star was 3, which is the next smallest digit, then the tens digit would already be 6. And then the hundreds digit would be 12, which doesn't work because it has to be a 3-digit number. So therefore, there's only 2 options, 421 and 842. The final question, problem 8. How many different even 4-digit numbers can be formed by using the digits 0, 1, 2, and 3? What is the second largest one among those numbers? Well, see here that how many different even 4-digit numbers can be formed by using the digits 0, 1, 2, 3, 4? Well, we have 4 choices, right, at first. And then once we know that there are 4 different choices, or from the 4 choices, you can either get 0, 1, 2, or 3. And then we see here that there are 2 cases. Case 1 would be that such numbers that end with 0, so end with 0. And these numbers would just be 1,230, 1,320, 2,130, 2,310, 3,120, and 3,210. And then case 2, such numbers that end with 2 this time. And this would give us 4 different choices, 1,302, 3,102, 3,012, and finally 1,032. And then we see here that there are 10 different choices. So first one is 10 choices. The answer is 10 choices. And then what is the second largest one among those numbers? Well, we can easily find that the second largest would just be 3,120 because 3,210 is the largest one. So therefore, the second largest is 3,120. And that is the solution video.